Okay, in this session, we are only going to focus on this concept, the concept of proving identities. You don't want to jump into it, all right? You want to get yourself armed with skills and then use the skills to deal with lots of questions. What are the skills of proving identities? All right, number one, identify all identities and change them to simpler identities. What do I mean? In grade 11, there are just a few that we need to know. What are the identities that we need to know? Sine theta over cos theta, that is actually equal to 10. That's the first one. The second one is the square one. Sine squared theta plus cos squared theta. Now, this one has a lot of variations. And this is where we lose it. Check the variations that I'm going to have. Sine squared theta can be written as 1 minus cos squared theta. And that's not the end. That is actually difference of two squares and can be written as 1 plus cos theta, 1 minus cos theta. Take note. Difference of two squares. Cos squared theta the same way. 1 minus, if I move that sine squared over, becomes, and that's also what? 1 plus sine theta, 1 minus sine what? Theta. Identify all identities. So these are the identities that we're going to be looking for in terms of simpler identities. Then we change. Number 2, never. Okay, that's general solutions. Then let me bring that in. Number 2 is simplify fractions. By using, I call it the DDD principle. Diagonal is just a simpler way of dealing with fractions. Diagonal and denominator. So A over B plus C over D. The first thing is we multiply the first diagonal, A times D. I hope you've seen my first diagonal there. Multiply that. Second one, multiply that, but there's a plus in between. Then the third one, multiply the denominator, BD. Life will be easy. I promise you. Diagonal, diagonal, denominator. Life becomes a lot easier to deal with. Number 3. Okay, I need to go to the next page, write number 3 for you. You just give me thumbs up when you're done. It's okay, Sitley. When if you find it, you'll be able to walk through whatever, using whatever I'm going to guide you with. All right, number 3. Watch out for trinomials. It's not really common in grade 11, but it's something you need to be prepared for. Watch out for trinomials and be able to simplify your trinomials. Okay, what do I mean by trinomials? For example, you could have, check this, sine theta plus cos theta if I square this, what would I have? I'll be having sine squared theta plus 2 sine theta, although like I said it's not common, plus cos squared theta. So check the trinomial there. And if it's a minus in between there, so always try to look out for trinomials. Sine squared theta minus 2 sine theta cos theta plus cos squared theta. Just look out for it. You might not find it in grade 11, but I've seen a few questions. Number 4, the last one. Start from the complex. Okay, second to the last one. Start from the complex side. Always, it's always easier. Number 5, in exceptional cases, you can prove both sides to a common point. You can, or then let me say, you can prove, simplify both sides simultaneously to a common point. You are allowed to do that. That is, if you cannot get it, you prove the left hand side to a point. You prove the right hand side also to that same point. If they give you the same expression, then you're done. Left hand side will be equal to the right hand side. I think we have about 6 questions ahead of us, and you would see me using the same principles that I just explained to you. If there's anything, I'll come back and add to the page. All right, I'm sure we are ready for this journey. Look for the complex side, people, and start from there. In exceptional cases, you can simplify both sides simultaneously to a common expression, to a common point of expression. I forgot that. Okay. Let's go prove. Here's the first one. I'd like you to respond. Which one is the complex side? Is it the left? You're not mandated to start from the left or mandated to start from the right. Look at the question. Which one do you think is complex? Sidley, which one is your right? How can tan theta be complex? The left hand side is the complex one. All right? The left hand side is the complex one. So I'm going to start from the left hand side. And my first point says, identify, all right? Oh, by the way, let me also guide you with something here. Let me guide you. Look at where you are going. You're going to get what? Tan. And what is tan? You know tan is what? Sine theta. So that is your aim. Your aim is to get sine theta over what? Cos theta. All right, let's see. Let's identify all our identities. Sine theta is not an, it's just a simplified one. Minus, now what is tan? Please, the way you write will determine how fast you get this thing. Minus sine theta over cos theta, that is my tan. Already I have 1 mark. Multiplied by cos squared theta, all right, over, I could actually put over 1 here and put over 1 here, but remember I am multiplying there. So be careful of how you write. And then what you have here, now you have what? Cos theta minus 1. Do you notice that 1 is also an identity, which could give us a problem? So let's try to change it. cos theta minus, please, there's a bracket when you change that one, sine squared theta plus cos. That was just one, right? Let's enjoy maths. That is just one. And then we have what? Plus sine squared theta. Everything done step by step. What do you notice here? This one here would take out one of the cos's. So what do I have? I have sine theta minus sine theta cos theta over, okay, we don't know, we'll just keep at it, expand. Sine squared theta minus cos squared theta plus what? Sine squared theta. We expand the bracket. Then I'm seeing something here, simplification. Negative sine squared theta, positive sine squared theta. Okay, so I have sine theta minus, the way you write will actually guide you. Cos theta minus, you need an eagle eye. Something is common. I don't know if you see. What is common at the numerator? Sine is common. Algebra. Sine theta is common. Open a bracket. What do you have? 1 minus cos what? Theta. Over. What's common at the bottom again? It is cos theta. 1 minus. We've taken 1 out, so we are left with 1. Check. We have sine theta over cos what? Theta. And what's your answer? Tan theta. We're done. The left hand side is now equal to the right hand side. Please talk to more. Hello. Mm-hmm. Where? Which second step? Show me which. Tell me. Go through the board and tell me.
Sine theta over 1 minus sine theta over cos theta times cos theta.
Okay, we are not cross multiplying there. We're just multiplying. You have 5 over 2 times 2 over 1. What's your answer? These two are multiplying, so that these two can divide. Because what this cos squared theta means, if I were to break it down, what does cos squared theta mean? It means cos theta multiplied by what? Cos theta, if I do it that way. And it's over 1 over 1. We're not cross multiplying. It's just with algebra, when you with fractions, you multiply the top, and with fractions, if it's a fraction, a over b times c over d is actually a times c over b times d. Multiply the top, multiply the bottom, and then you can see whichever one are multiples of each other and then divide. All right, let's go to the next one, and I'll give you a moment to try first. Oh, no, let me do this one. I want to do this one because it's a fraction. I want to do this one. So the next fraction you see, you will do. Now, I told you something about fraction. D, D, D. Diagonal, that diagonal first, next diagonal, and then denominator. Check what I'm going to do. Left hand side, let's multiply. The top left times the bottom right. 1 times 1 plus sine theta will give us what? 1 plus sine theta. Please follow my lead. I am multiplying this and that. Then I'm going to multiply this and this. But there's a minus in between them. Minus. Now what is cos theta times cos theta? So I am done with my 2Ds. Diagonal, diagonal. So I did the first diagonal, I did the second diagonal. I am going to do the denominator. Just multiply it. Cos theta into bracket 1 plus sine theta. That's what I have using my DDD. Which identity can I get rid of? Look, if you like, you can get rid of 1. It could be easier. What is 1? Sine squared theta plus cos squared theta plus sine theta minus cos squared theta over cos theta 1 plus. Now let's simplify. Do you see? Once you change the 1, things start falling out. Now, let me write this out. I told you it's all about be patient. Write it out neatly. I'm not even going to expand. Write it out neatly. Now, what's common at the top? Sine theta. What do I have in the bracket? Sine theta left here plus 1 over cos what? Theta 1 plus. I don't know if you notice that your brackets are the same. I'll leave it there so that we can then see. What do you have? Sine theta over what? Cos theta. And that is equal to diagonal, diagonal, denominator. And look, the skill here is, I saw where I was going. I needed to get sine theta over what? Watch this. And I'm already seeing that I've got a cos theta out here. That's why I didn't expand in. Some of you would expand in and get confused. All I needed to do was to get a sine theta that will have the same value or the same bracket as that. So I kept my cos theta out and aimed to get the same thing so that it cancels out there. I want to give you one on for yourself to do. I hope we are ready. You get your 5 marks. So change all the identities that you can see. If it's a fraction, diagonal, diagonal. It has never failed me once. Diagonal, diagonal, denominator will always be an everlasting principle. It's just using your LCD but in a different way. Okay, are you ready to take one on? We have about 6 to do. I've done 2 already. Let me see by a show of interest that you're ready to try the next one all by yourself. Okay, sweet. And there we go. Sorry, you chose this. Great. 4 marks. Don't be scared about the square root, okay? Don't be. I'll talk to you after 6 minutes. Let's give you 6 minutes for you to catch your breath because of the square root. Oh, Google pushed. Done. Chess, Angela, Seatley, Sikulile, come talk to me. Are we stuck? Let me know if we're stuck. Look, why don't you start with the fractions? You see, that's what I did. Don't worry about the 10 and the squared. Don't worry about that. Why don't we start with what's in the bracket, under the square root? So, for me, I would say 10, all right, left-hand side, So I'll say 10. Oh, I could actually change that into sine over cos if I want. Sine theta over cos theta. Now, we did denominator, diagonal. This is over 1. So what is 1 times 1? 1 minus, we multiply that. What do you have? Sine squared theta over what? Over, multiply the denominator again. Oh, this is actually a lot easier than I thought. Sine theta over cos theta. Now, identities. We spoke about 1 minus sine squared. You see, you need to keep an eye on that. That is actually equal to cos squared theta. I don't know if you notice. So this is what? Cos squared theta over sine squared theta. Now, what is the square root of that? So this is sine theta over cos theta multiplied by square. All right, this becomes cos theta over sine what? Theta. That divides, and that also divides, and your answer is 1. We're done. Algebra. Where are you? Where were you guys stuck? Where were you stuck, guys? Diagonal denominator, the square root of 2 numbers that I'm dividing. Yes, Kito?
So you square the square root and the sine theta over cos theta to get second last bit, right?
Yeah, the square root of. Yeah, the square root, because the square root houses everything. You see, if I want to take you through the baby stage, would be to let you see this, that this can be written as a over b all squared, and I still have a square root. That just take care of each other. Because if I don't want to do that again, square root simply means to the power half. Do you see? I'm still going to get a over b. So if I have cos squared theta over sine squared theta, root will simply be cos theta. Since there's no plus and minus in between, you know, you're very flexible mathematically. And these two takes care of, the square takes care of the square root. What I have left is cos theta over sine theta. And that's it, guys. Cheslin, Sikulili, and Sitley. Okay. So it's more of bring all the algebra that you know along the way. All right, let's go for the next one. Remember, you are going to then have a chance to always try before I come through. Let's see this one. Oh, 4 marks. Please, we must get this one correct. 6 minutes. Okay. Once you are done before 6 minutes, let know. Race for time as well. But more than time, accuracy is important. So we need to keep a balance of both. Oh, everyone seems to be done on this one. Thank you very much. I see the done. Okay, let's see. What's common? So again, your aim is to get sine over what? Cos. This is, oh, I see why you guys are done. Quickly, sine theta is 1 minus, I have cos theta there, over, let's simplify this, it's going to be cos theta minus 1 plus, oh wait, hold on. There's no need to do that. 1 minus sine squared theta is actually cos squared theta. Right? I don't know if that's what you did. This is cos squared theta. So, what we have here is sine theta 1 minus cos theta over cos theta is common. 1, okay, let me get rid of this bracket. It's of no use because 1 minus sine squared is cos squared. So 1 minus cos theta. And your answer is sine theta over cos theta, which is equal to 10. Beautiful. Next. Six. Don't worry, the 4 will come from where it will come from. Just do what you need to do. What's going on here? I'm not getting responses at all. It's like a quiet, a dead class. What's up? Talk to me. Are we stuck? Can I get responses from every other person? Jesse. Guys, I think, okay, let's see. I think if we follow the principle, I think we should be fine. All right, diagonal, denominator. So I'm multiplying the first diagonals, this and that. So, and then this and that, right? Okay, so what would I have? Let's do it step by step. Don't rush it. 1 plus sine theta into bracket 1 plus sine theta, that's my first one, minus is between the two terms, then 1 minus sine theta, 1 minus sine theta, everything over the denominator, 1 minus sine theta, 1 plus, I think if you go back to my first note, I'm seeing something similar. That denominator is something I've seen before. All right, let's try to expand because there's nothing we can do. We have to expand. This is 1 plus, I'm sure we all know, it's going to be 2 sine squared theta plus, 2 sine 2 theta, 2 sine theta rather, because it's 1 times 1, 1 times sine theta. We're just doing our normal trinomial, right? Foiling. Plus sine squared theta minus, there's a bracket there. What do we have? 1 minus 2 sine theta plus sine squared theta over, if you expand this, let's see. This is difference of two squares. You're going to get 1 minus sine squared theta. Guys, just follow the maths. Do the maths the way it should be done. I'm sure we're going to get somewhere. Let's check. 1 plus 2 sine theta plus sine squared theta. Now let's expand the bracket. You must have broken a math rule. Negative times positive there, negative times negative. If you're not getting it, you are breaking math rules. That's what you're doing. Over 1 minus sine squared theta. Let's see. I am seeing that this guy and this guy would automatically go. 1 and minus 1 would go. All right. I am seeing my 4 already. 4 sine theta over, now what do you have? 1 minus sine squared theta is what? cos squared theta, which is cos theta multiplied by cos theta, because I see what the examiner wants. Cos squared is cos times cos. Now, what do you notice here? What is that? That is 10. And I still have a cos theta at my denominator. Done. All right. So once you break a rule, maths would break you. Break a rule, maths breaks you. Check. We didn't have even...
So,
yeah?
so where did you get the other sign? Where did you get the other cos?
What is 1 minus sine squared theta? It's an identity.
Yes, sir, but that's only... Oh, okay. I get you.
Cos squared theta, which is cos theta multiplied by cos theta. So it's much of simplification and the 4 identities that I expanded for you. All right, guys, so I hope it's making sense. Approach it with ease. Don't break any algebra rule. Maths would remain maths. Okay. I don't know how many we have left. Let's see. Oh, we just have 2. We just have 2. 2.4. Get through 2.4 for me quickly. 5 marks. Please try. Let's get this one right. Let's give you a time frame there. 5 minutes. You should have started while I'm trying to get my... Yeah. Change all identities into simpler identities. What's up here? This doesn't look difficult. Come on. This doesn't look difficult. Why are we still delaying? It doesn't look difficult. Maybe it's the fraction. What is 10? 10 is simply sine theta, okay, left-hand side, over cos theta minus sine theta over 1. And that is 1 minus. All right. Let's do our DDD. Sine theta times 1 would give us sine theta minus that times that will give us what? Sine theta cos theta. Everything over cos theta, right? To make my life easy, I'm going to then say divided by 1 minus cos theta. I'm just rewriting it. So the entire top here is what I did here by using my d, and then divided by this over 1. What's common here? Sine theta is actually common. 1 minus cos theta over cos theta times algebra 1 over 1 minus cos theta. If you check, that goes. What do you have? Sine theta over cos theta. We're done. And that is equal to 10 theta. Again, done. Nothing much. Nothing much. Identify the Identify the identities, change them. If it's a fraction, d. Then factorize, simplify, you're done. Are we okay here? Are we okay? right, let's see. Proof identity. I want you to try. I want you to try again. Six minutes. You try again. Give it a trial. Give it a shot. Why? All right, so the first natural thing I would do here, all right, is to see this as over 1, okay? And let's see if I were, and automatically that 1 minus cos squared is actually sine squared y. Let's try to see if that will help us. So, if I use my diagonal, what would I be having? I will be having tan squared y, all right, plus, if I multiply the other way around, 1 over tan y. Let's see where it's going to lead us. And this should give us 1 minus cos squared is sine squared y. Okay. Let's try. Let's see where we would get to with this. Now, if I multiply the top, all the top and the bottom there, okay, check this. I'm seeing something here. What I'm seeing here is this can be written as tan squared y, or if you like, we could have used sine and cos if you want. We would still probably get the same thing. I think, let me try that first. What is tan y? It is sine y over what? Cos y plus, what is 1 over 10? It is now cos over sine, okay? This might actually help us more. And then here, 1 minus that, we said this is sine squared y. Let's see where this would lead us. Okay. If we then continue, we have sine squared y plus cos squared y. Remember, this times this, sine squared, that times that, cos squared, okay? And that is over what? Sine y, cos y, everything multiplied by sine squared y. All right, this is over 1. Now, I can actually throw that off, all right, such that I then have, what is sine squared y plus cos squared y? 1 over cos y multiplied by what? Sine y over 1. And this is sine y over cos y. And that is actually equal to 10y. Done. Change, I'm still using the same principles we spoke about. Change your identities into simpler. And 10 can simply be changed into sine over cos. And my 1 minus cos squared y has become sine squared y. Done. Alright, so that's why I changed it. I went back to my own rule. Change. Why don't I change the 10 into sine over cos? Follow the rule. Not you posting you are now overdone with trigs. No. You still find it next year. Whether you post or not, you still find it next year. So, get in with the program quickly. Alright? Get in with the program. I'm not using any other system apart from the things I wrote, the rules I wrote. There's this question that I'm just interested in as we were preparing. Let's see what this question is all about as we. So guys, check your textbook, find questions. Let's practice more, but use those principles. Okay, I'm interested in this one. If alpha plus beta equals to 90, determine without the use of a calculator. Do you want to try? Let me give you just 5 minutes to try, then it's our last question for the day. But I want to believe you have now been equipped with some important tools. You just need to fine-tune and use them over and over again. Okay, 5 minutes. What is this? It's alpha. Done. The 2 is done. Sitley, that means you are not following. I said I'm just going to use angles. All right? Because 30 plus 60 would give me 90. You can try 45 and 45. You can try any two numbers that are complementary. Any two numbers. I was just trying to prove the answer. I was just trying to. So you check how we work things out. Check how maths can be so sweet. How maths can be so beautiful. Understand the process. Guys, in your cloud class, I have posted everything you need to know about trigs from the beginning to the end, including these lessons of proving identities. They are all there, 2D, 3D graphs. Dive into it and get yourself sorted. Understand. Once you understand trigs in 11, grade 12 is the same thing. Are we okay now? Did it make sense? And your co-ratios there, if those two angles will give me 90, then I can switch my sine and the cos. That is why cos 20 and sine 70 are the same. Now, let me show you something. I am going to jump from here directly to this point. I'm not even going to say 360 minus what not. I am going to jump and I'm going to use my calculator. Check what I'm going to do. And you will not be penalized. Cos 700 equals to, you press that. Then you reverse the whole thing. Shift, cos, answer. It gives me 20 and I'm done. I've skipped all those 340, 360 minus 20. I'll do it again. Cos 700 equals to shift, cos, answer, 20. Because this is where the mark is. It's 5 marks. Your first mark comes from here. Your second mark comes from here. Your third mark would come from simplification there. Your fourth mark will come from changing cos 20 to sine 70. And your final mark will come from the answer. Check. No one gives you mark for this. Yes? You didn't change what?
What if you changed to cos 20 and not sine 70? Would it be the same thing?
Yeah, sine 70 is the same thing as cos 20. So you can change your denominator. Is that what you're asking? Hello?
Yes, sir. Yes, sir. Everything makes sense.
Yeah, it's the same thing now. So it's cos 20 over cos 20 because sine 20, sine 70 and cos 20 are the same. Minus 1. Doesn't matter whether you change from sine to cos or cos to sine, whichever one you can change. All right. And that's how to get your trigs. Trigs is very nice, guys. Very lovely. If you just get the bait, don't rush into doing questions. Go back. Let's go back into building content. Trigs becomes very nice. All right. Anyway, I'm sure that you were crying about proving identities, and I gave you 4 important or 5 solid points which I used throughout today. Identify all identities and change them into simpler. Tan is sine over cos. Sine squared plus cos squared theta is 1. Now start variating that. 1 minus cos squared theta. 1 minus sine squared theta. And those are difference of 2 squares. When you see a fraction, diagonal, diagonal, denominate. And you saw that we used it throughout today. Every time we came up with a fraction. Watch out for trinomials. I told that's not very common in grade 11. But in grade 12, it's there. Always start from the complex side. In exceptional cases, you can simplify both sides simultaneously to a common point of expression. All right. And now, Sitley, please go to your cloud class. I have classes already posted for you on proving identities and everything trigs. I sent you the link again. Was it yesterday or today? I don't remember. So please get into it. I'll be doing exactly what I've posted. So get into it and take enough time to assimilate and get the information. All right, guys, if there is no question, let me know if we are okay. Let me know if we are okay, if there's no question. Awesome. All right, then. Have a lovely night, everybody, and goodbye.